So what we're going to do in this video is look at some derivatives by just using the straight up power rule. So this is assuming no other knowledge of derivatives. So when knowing only the power rule, can we find these derivatives? So looking at this first one, this one is actually a rather basic example. You notice that it is just in polynomial form, so we can just use the power rule. And also remember the constant multiple rule and the sum and difference rule. So it seems like there's a lot of rules, but they're really just intuitive. So the derivative, which we'll call f prime of x, is equal to, now remember, if there's a constant multiple in front of the power of the variable, it just gets brought along. So I'm just going to write out 3 times 4x to the third minus 5 times 2x. And remember, the derivative of x is 1. And then, of course, we want to simplify our results. That means that this is 12x to the third minus 10x plus 17. And that's the derivative of the original f of x. So we're done there. Okay. Now, the key is remembering that there are other expressions like this square root and cube root expression here that can be rewritten as powers of x. So remember that square root of x is really x to the 1/2 power, and cube root of x is x to the 1/3 power. So now we're in the same boat as the first example. So that means that the derivative, g prime of x, is equal to 6 times 1/2 is 3. So that's 3 times x to the, if we drop the power down by 1, that's negative 1/2 power, minus 6 times 1/3 is 2. X to the 1/3 minus 1 is negative 2/3. And there again is your final answer. You could choose to rewrite in terms of positive exponents if you really want to. You could write 3 over x to the 1/2 minus 2 over x to the 2/3, and that again would be fine. And if you really want to impress your instructor, you could rewrite them as radicals. That's a little bit more difficult and probably unnecessary in most situations, but you may remember again that x to the 1/2 is the square root of x. I'm just going to write that as 3 over root x minus, now x to the 2/3, that's a little bit more involved. That's the cube root of x squared. And all three of those answers, 1, 2, 3, would be considered acceptable. So you can just stop at the highlighted one unless you are given further instructions. So this next one, now notice this is a quantity squared. So we can't exactly use the power rule because we only know how to differentiate single powers of x, or any variable really. So the first thing we're going to do is manipulate the expression. So squaring something means multiplying by itself. So I'm going to write this as 3x squared minus 4 times 3x squared minus 4, and then we're going to FOIL. So notice, no derivative has occurred yet. So first times of first is 9x to the fourth. The outers and the inners both give us negative 12x squared, so that's going to be minus 24x squared plus 16. And now we're ready to take the derivative because now it's in a form that we're familiar with. So you can write y prime or dy dx. It really doesn't matter which one you use. They both mean the same thing. Derivative is 4 times 9 is 36. Subtract 1 from the power, so that's 36x to the third, minus 24 times 2 is 48. X to the first, so I'm not going to write the first power. And then the derivative of a constant is 0. So that one is done. This is the derivative right here. And last but not least, how to deal with powers in the denominator. Remember that we kind of already saw that 2 examples ago, where if it's a power in the denominator, it's a negative power in the numerator. So this is 2 times t to the negative third minus 3 times t to the negative second. And then the derivative, keeping the variable the same, bring down the negative 3 times 2 is negative 6, t to the negative 4. We have a minus 3 times a minus 2, so that's a positive 6, t to the negative 3, subtracting 1 from the power. And if you really want to, you can rewrite this in terms of positive exponents. Again, not necessary, but it does help with familiarity when we're dealing with the expression later. Having to plug values in and such. We could write this as negative 6 over t to the fourth plus 6 over t to the third. And admittedly, that actually does look prettier. So either one of these expressions would again be acceptable unless you're given some kind of instruction. So there's some derivatives by using the power rule. I hope that helps get you going with derivatives, and come back for more videos on other rules of derivatives. Thanks again for watching.